Hey, second through fourth grade. We are going to continue on with our nonfiction unit. About a week and a half ago, we were able to start shattering earthquakes. Okay, and I want to tell you a little bit more about this book. There are two types of books. We have fiction and nonfiction. Fiction, I like to remember as fake because they both start with F. Fiction, fake. Nonfiction is about true things. Okay? So things that actually happen. And it has a very special name too. We can also call it expository. So we're going to read about real happenings in this Shattering Earthquakes book. Now, on the very first page of a nonfiction book, they include what we call a table of contents. And a table of contents is when they tell you what you're going to read about and the pages that you might find those on. So, a week and a half ago, we were able to read about what is an earthquake, and we found that on page 4. Now, we're going to read about what causes an earthquake, and we're going to find that starting on page 6. So I would like to read a little bit from this book to you, but I'd also like to show you some things in my house that I made for you so that we can comprehend or understand our book and our topic of earthquakes a little bit better. So let's go ahead and get started. Okay, I found page 6. All right. What causes earthquakes? This is our heading. It's going to tell us about that. Earthquakes are movements of the ground. They usually happen in certain special places, not everywhere, but in certain places because of the way the earth is made. To understand how earthquakes happen, we need to know a little bit more about how our planet was formed. So today, I know you can't see it when you go outside because there's snow covering it. But what's underneath the snow? Dirt, rocks, right? So what I've done for you is I've created something to show you a little bit about how our planet was formed in addition to what we read here. Okay? Well, that surface underneath the snow is a layer of hard rock and dirt and mud, and that's called the crust. It forms most of our land and what's on the oceans, okay? Under the crust, there's more rock. Now, the crust is a very thin layer, and underneath that is called the mantle, and the mantle is very thick. Millions of years ago, the mantle rock cracked like the shell of an egg. So, if we're thinking about an egg, what happens when you crack an egg? Well, the pieces crack into little tiny parts, and then liquid comes out because that mantle or the eggshell was holding that liquid inside. So millions of years ago, when our earth cracked, it left these big pieces because our planet's huge, and we call those pieces tectonic plates. And what they do is they just float around on that liquid that was holding it inside. And that liquid is our third and fourth layer. It's called the core. There's an outer core and there's an inner core. And those are made of very, very hot, molten rock called magma. It's very hot. All right, so in order to better understand this, I've made this little earth thing, okay? And I made it out of Play-Doh so it can show you just a little bit better how our planet was formed. So this green area, I made it green because there is grass on top of our dirt. It's very thin in comparison to the other ones. And it's on the very outside of our earth, okay? Underneath that, we have this yellow color, and that's our mantle. It's very thick. Now, millions of years ago when it cracked, and you can see all those cracked pieces, it broke apart into those shattered plates that we're going to call them, and it now rests and floats on these two layers called the core. The orange is the outer core, and the red, the super hot part, is called the inner core. So this is kind of what our Earth looks like on the inside. Right, let's put that aside. Okay, and we've also got a picture right here. This is called a diagram because it points to the parts of our Earth. All right. We're going to talk more about the plates now. As the plates move, they rub or they slide against each other as they're floating on that core, the magma. The place where the plates meet is called a fault. So the little tiny gap where they meet at is called a fault, and that is where most of our earthquakes happen. In most places, a plate will slide against another in a slow and steady way. So think about when you're walking in the hallway or in a store and you accidentally bump into someone. What happens to them? You cause them to move a little bit, right? Well, that's what happens with plates too. When they run into each other, they move the other one and everything on top of it. Most plates, though, move at a speed of only a few centimeters per year. Okay? That's about the same rate of growth as your fingernails. So however much your fingernails grow in a year, that's how much a plate moves. Not that much. Sometimes two plates get stuck against each other. For many years, they slowly push harder and harder and build up a lot of force. And then suddenly the force becomes too much and these gigantic plates of rock slip past each other. And when that happens, the crust or the dirt and the ground above shudders and shakes and quakes. And that is what creates your earthquake. The force of the plates suddenly jerking apart can open cracks even in the crust above, like the one you see in this photograph here. All right, we're going to do a little exercise with our hands. So I want you to take your fists and put them together like this. We're going to pretend that our hands are tectonic plates. Now, if we squeeze them into fists and we put them together with our knuckles touching, okay, we're going to pretend that that crack in between our knuckles is the fault line, okay? And these are the two plates. So when we turn them like this and try to push forward or backward, do you feel what's happening? It's not smooth at all. It's really bumpy and rough when we try to move them against each other, okay? Because there's so much force in there. So when they slide past each other, that's one way an earthquake can happen. There's two more. Now, the other part when an earthquake can happen is when these plates move apart and they pull away from each other. Can you guess what happens to the ground above that we stand on? Can you guess what happens to them when the plates pull apart? What's in between the plates? A gigantic gap, okay? And sometimes, if it's enough that it moves apart, it'll make a crack in the earth, just like this one, but not a really scary deep one, not usually. All right, the last way that earthquakes can happen is we're going to lay our hands flat, and I want you to touch your fingers like this and push really hard against each other. What's going to happen? Oh, okay. These plates have so much force that they make your hands go up against each other. And I'm guessing that you can think about what's happening on the earth when this type of earthquake happens, okay? It will cause hills or mountains, okay? So what happens below our crust affects what happens on top of it. And that is the three types of earthquakes that can happen. All right, I want to read to you one more part. We're going to talk about shock waves. Okay, now because the plates are sitting on this liquid, they move sort of like in waves, just like water, like this. Okay, all right. So I want to read to you a little bit about those waves before we get done today. The point on an Earth's surface above the very start of an earthquake is called the epicenter. It's a Very neat word. And it is right where the earthquake starts, so right at the tip of my finger. The force of an earthquake spreads out in waves from the epicenter in all directions, so surrounding that spot. These movements are called shock waves. Shock waves ripple through the rocks all around the epicenter like ripples on a pond when you throw in a stone. Shock waves can travel for hundreds of miles, but they get weaker the further they are away from the center. So I want to show you a little bit of what happens in water, just like what would happen with an earthquake. Okay. All right. I'm going to show you this tub of water right here. Now, earthquakes can be really weak and we can barely feel them, or they can be really strong and cause a lot of damage and destruction. So, I've got a little teeny pebble I'm going to put in here, and I want you just to watch what happens to the water when the pebble drops. Did you see those waves go out? Let's try it one more time. Do you notice those ripples? Okay, now I'm going to put in a bigger object, and I want you to look at the very center, the epicenter, okay? Because the splash or the wave is going to be a lot bigger than what it is as it spreads out toward the sides. Here we go. Okay, one more time. Notice how big it got here, but then as it spread out, it got a little smaller. Okay, so it's strongest the closer it is to the epicenter, and then the more it spreads out, it gets a little bit weaker. So that tells us that on the crust or the ground that we walk on, the closer we are to the epicenter, there's going to be more destruction there at the very beginning than there is way far away. We might not even feel it that far away. All right, thank you for joining me today, 2nd through 4th grade. We'll read more about shattering earthquakes in the days to come. Please do your assignment or your homework in your pink October 26th folder, okay, for week 8. Make sure that you listen to the audio recording. You'll record a video of yourself answering those 3 questions. Good luck.